In a basement laboratory at the University of Arizona in 2009, a physicist named Greg Hodgins fed a sliver of 600-year-old calf skin into a machine that counts carbon atoms one at a time. The numbers settled. The parchment was made between 1404 and 1438. Just like that, the most mysterious book on Earth had a date. The headlines wrote themselves: The Voynich Manuscript. Solved. But that date belongs to the skin, not to the ink, and not to a single one of the words. And the test everyone assumed was done to the writing was never done. What actually happened in that Arizona lab was this. Hodgins took 4 tiny samples, cut from the edges of 4 different pages, and dated the parchment itself. The result was rock solid. It is some of the best science ever done on this book, and it settled one argument for good. For centuries, people had guessed the manuscript might be the work of the medieval friar Roger Bacon, writing in the 1200s. The carbon date killed that idea in an afternoon. Bacon had been dead for 100 years before this calf was ever alive. So the skin is real, it is medieval, and it is early 15th century. That much we know. But a book is not its paper. The words on a page can be written the day the parchment is made, or a lifetime later, or, if someone is patient and dishonest, centuries later. Carbon dating the calfskin tells us when the animal died. It tells us nothing about when a human being sat down, dipped a pen, and started writing in a language nobody on Earth has ever been able to read. And that raises the obvious question, the one that shows up in the comments under every single video about this manuscript. If they dated the parchment, did they date the ink too? The answer is no. In 600 years, through every study, every imaging session, every team of scientists who has ever touched this book, the ink of the Voynich Manuscript has never been carbon dated. Not once. And this is not a small book with a page or two of scribbles. It is roughly 240 pages, dense with looping script and hundreds of drawings, plants that match nothing in botany, women bathing in strange green pools, circular diagrams of stars. Every one of those pages carries ink, and none of it has a date. You may even have a vague memory of hearing that the manuscript was decoded, maybe more than once. Those stories surface every few years, collect a wave of headlines, and quietly fall apart. Everyone so far has been wrong. When you first hear that the ink itself has never been tested, it sounds like an oversight, or worse, like someone avoiding the question. We assumed the same thing. If you can date the page, why on earth would you not date the writing on it? The actual mystery, the thing everyone wants explained. It turns out there is a reason, a real one, buried in the chemistry of what medieval ink actually is. And to understand it, we go back to 2009 to a second laboratory and a man with a microscope. His name is Joseph Barab, a senior microscopist at McCrone Associates, a materials lab outside Chicago that has spent decades telling museums which of their treasures are real and which are fakes. Barabe has worked on the ink of the Gospel of Judas. He has caught forged manuscripts that fooled universities. In 2009, the Voynich pages came to his bench. Under the microscope, and under a battery of tests that fire electrons and X-rays at a sample to read its exact chemistry, Barabe took the ink apart. He found the main text was written in iron gall ink, the standard ink of medieval Europe, made from crushed oak galls and iron salts. He found the blues were ground azurite, the greens were copper-based, the reds were ochre. And here is the part that mattered. Every single material was consistent with the early 15th century. Nothing was modern, nothing was out of place. No pigment that had not been invented yet, no chemical fingerprint of a later forger. If someone faked this book, They sourced perfectly period-accurate medieval materials to do it. There was even a strange wrinkle in the ink. Barabe found not one ink, but 4. The main text and the drawings share a single iron gall ink, but the page numbers were added in a second ink, heavy in iron. And the little numbers marking the folded gatherings of pages, along with a short row of Latin letters on the first page, were written in a third and fourth ink, high in carbon, low in iron, different from the text itself. That detail is easy to skip past, and it matters more than it looks. It means someone came along after the book was finished and numbered its pages in a different ink. Someone handling a completed book they could not read, trying to put it in order. The unreadability is written into the object's own history. But notice what all of this testing could and could not say. Barabe could tell you the ink was the right kind of old. He could not tell you when it was applied. Being medieval in its recipe is not the same as being written the year the parchment was made. And that gap is the whole problem. It is also why the obvious fix, just carbon date the ink and settle it, runs straight into a wall. Greg Hodgins, the same physicist from the Arizona lab, explained why he dated the parchment and left the ink alone. Carbon dating needs carbon, and it needs a certain amount of it. Parchment is animal skin, almost pure organic carbon, so a small, clean sample gives a clear reading. Ink is a different animal. It sits on the surface in trace amounts, a thin film only a few atoms deep. Its carbon content is tiny to begin with, and with iron gall ink, the little carbon it does contain is bonded into the ink and pressed directly against the parchment underneath, which is a vast reservoir of its own carbon. There is no clean way to separate the two. Try to date the ink, and you are really dating the skin it is sitting on, plus a rounding error of ink. To get enough ink for an honest reading, you would have to scrape away a wide stretch of the actual writing. You would have to destroy the very thing you were trying to study. Sit with what that means. The words are right there, in front of the scientists, under bright light, photographed in perfect detail. And the age of those words is locked behind a door that current science cannot open without burning down the room. So we are left with a gap, a real, measurable, unavoidable gap between the one date we have and the one date we want. And that gap is exactly where the trouble starts. The trouble, stated plainly, is this. The calfskin was made in the early 1400s. We do not know when the ink went onto it, and that unknown interval is the crack every alternative theory tries to climb through. The most aggressive version comes from a researcher named Rich Santacoloma, and it is worth saying up front that this is a minority view, rejected by most scholars who study the manuscript. His argument runs like this. When Wilfrid Voynich, the rare book dealer who gave the manuscript its name, bought a huge lot of old books in Italy in 1908, he could have come into a stack of genuinely old, genuinely blank medieval vellum. Old blank pages, centuries old, waiting for someone to write on them. In that story, the parchment is medieval and the writing is a hoax, produced around 1910 by Voynich himself to sell. It is a tidy theory. It explains the carbon date without accepting the mystery. And on paper, the physics allows it, because dating the skin can never rule it out. Writing on blank vellum centuries old would be unusual, since medieval scribes generally wrote on fresh skin, but unusual is not impossible. So the theory survives on the chemistry. It is the moment you stop looking at the chemistry and start looking at the book as a physical object that the tidy story runs into problems it cannot solve. Look closely at the pages, and the book starts. Arguing back. On several folios, the painted color and even the writing run right into the fold at the center of the binding, vanishing into the gutter where a pen could not comfortably reach once the book was sewn together. That means the drawing and the writing came first, and the binding came after. On other pages, wormholes bore straight through finished letters, little tunnels eaten by insects that pass cleanly through the ink. Worms do not eat blank paper and politely wait for a forger. They came after the words were already there, over a long stretch of years. And the parchment itself is uniform across the whole book, page after page, of consistent calfskin, not the mismatched patchwork you would expect if someone had scavenged random old blank leaves from a bookshop. None of this is proof of innocence on its own, but it stacks up, and it is a strange kind of evidence to fake. We are about to get to the single strangest thing hidden on the very first page of this book, a discovery that only surfaced in 2024. If a 600-year-old object that fights every test this hard is the kind of mystery you want more of, take a second to subscribe, because chasing exactly these questions, the real sites and the ones nobody can close, is the whole reason this channel exists. Now, that first page. Before we get there, one more thing scientists checked early. They wanted to know whether the Voynich Manuscript was hiding older writing underneath its own, a page scraped clean and reused, which was common in the medieval world when parchment was precious. If there were an earlier, erased text beneath the Voynichese, that would change everything. So they looked, with microscopes in 2009 and with multispectral imaging in 2014, a technique that photographs a page under many different wavelengths of light to pull out ink the naked eye cannot see. The verdict was clear. There is no hidden layer. The manuscript is not a reused page. Whatever this is, it was written onto fresh parchment, on purpose, the first and only thing those pages ever carried. The book we have is not quite complete, though. At least 14 of its pages are missing, some of them neatly cut out at some point in its history, and no one knows what was on them. But that same imaging, the very scan that ruled out a hidden text, quietly captured something else on the first page. Something nobody looked at closely for another 10 years. And when someone finally did, in 2024, it turned into the most surprising thing this manuscript has produced in a generation. In 2014, a team of imaging specialists photographed 10 pages of the Voynich Manuscript under multispectral light, capturing detail far beyond what any eye could see. Then the images sat, unexamined, in storage for a decade. In 2024, a manuscript scholar named Lisa Fagan Davis, one of the most respected paleographers working on this book, asked the team whether those old scans still existed. They did. They sent them over. And when Davis looked at the first page under that light, faint marks swam up out of the parchment that had been invisible for centuries. In the right margin of page 1, 3 columns of letters. Alphabets. Someone had written out rows of characters, and the handwriting was not the original scribe's. Davis matched it to Johannes Marcus Marzi, a scholar in Prague who owned the manuscript in the 1660s. What she was looking at was Marzi's own attempt to crack the code 400 years ago, a private worksheet where he lined ordinary letters up against the alien script, trying to force a key. It had been sitting on page 1 the entire time, hidden under a stain for 3.5 centuries. 2 of the characters he copied out appear nowhere else in the surviving manuscript, which hints they may have come from one of those missing pages. And that stain itself has a culprit. Wilfrid Voynich, around 1914, desperate to read a faded signature on that same page, brushed a chemical reagent across it to bring the writing up. It worked for a moment, and then it left a dark blot that buried the very thing Davis would need modern light to recover. 2 men, 300 years apart, both trying to unlock the same page, both leaving their fingerprints on it, both defeated by a book that still has not given up its meaning. And it is the number of hands on this manuscript that leads to the next problem for anyone who thinks one person faked it. Davis did something else that reshaped how we read this book. She ran a careful study of the handwriting across all 240 pages, comparing the exact shapes of individual characters the way a forensic analyst compares signatures. Back in the 1970s, a researcher named Prescott Currier had already noticed the manuscript seemed to be written in two different hands. Davis pushed that work much further. She concluded the Voynich Manuscript was not written by one person, or even two. It was written by five distinct scribal hands, each with its own quirks, all working in the same bizarre script. Sit with what that requires. A single forger, faking a book in 1910, is one thing to imagine. But five people, all fluent enough in an invented writing system to produce page after page of consistent text in it, all collaborating on the same object, is a completely different order of difficulty. It points away from a lone hoaxer at a desk and towards something a hoax struggles to explain. A group of people who all somehow knew this script well enough to write it naturally. Which brings us to the part of this story that is easiest to overlook and hardest to explain away. It has nothing to do with the code. It has to do with what the book cost to make. This book was expensive to make. Parchment in the 15th century was not paper. It was skin, prepared by hand, and it was usually the single most costly part of producing any book at all. To make the roughly 240 pages that survive, someone needed the hides of around 14 or 15 calves. That is a herd. That is a serious investment of money and labor, months of work by a skilled scribe on top of the raw materials, all poured into a book written in a language that, as far as anyone can tell, no one else could read. So whoever was behind it had real resources, or a wealthy patron who did. And here is the strange part. For all that expense, the book is oddly cheap in its craft. The pages are not ruled with the careful guidelines a luxury manuscript would have. The painting is often sloppy, color slapped down outside the lines. This is not the polished showpiece you would expect from someone rich enough to buy 15 calves. It is something else entirely. Someone spent a small fortune to create a large, laborious, deliberately unreadable book, and then did not bother to make it beautiful. That combination, real money and no interest in showing it off, does not fit a simple forgery, and it does not fit a rich man's vanity project either. It only deepens the question of what this thing was ever for. Which brings us back, finally, to the ink and to the emptiest chair in this whole story. 600 years after someone dipped a pen and began writing, no one has ever dated that ink. And now we know it is not because a curator at Yale is guarding a secret, or because a test was quietly refused. The Beinecke Library, where the manuscript lives today, keeps it under tight restrictions, but the reason is fragility. A book this old and this delicate cannot be handled freely, and that is ordinary conservation, not conspiracy. The real reason the ink has no date is simpler and stranger than any cover-up. The physics will not allow it. The carbon we would need to read is too scarce and welded too tightly to the skin beneath it for any machine we currently have to separate the words from the page they sit on. So the manuscript keeps its real age, not because someone is hiding it, but because we cannot yet ask the question in a way the science can answer. We can date the animal to within a few decades. We cannot date a single word the animal was turned into. The one number that would tell us whether this is a genuine medieval mystery or the most patient hoax in history is sitting right there, in plain sight, in ink. And it is the one number the manuscript refuses to give up, which is its own kind of answer. If a book that keeps this many secrets is your kind of story, the sealed chamber behind Tutankhamun's north wall keeps one just as stubborn, and we opened that door next.